2 power 7. So you're multiplying 2 7 times. So that gives you a sample space of 1, 2, 8. So if you toss a coin 7 times, the total sample space will be, so 2 to the power of 7. All right, now let us look at the part B. So it is similar. So if a fair die is tossed 7 times, so how many different outcomes are possible? So if you toss a die, so the probability of getting the sample is 6. Okay, either you get 1, 2, 3, 4, 5, or 6. So since you are tossing this 7 times, so the sample space will be 6 to the power of 7. So it is a very big number. So discuss the different ways in your answer to A and B. So what are the differences? So the difference is that there are 2 mutually exclusive and collectively exhaustive events in tossing a coin. So when you toss a coin, the 2 events are getting a tail or getting a head. And the total probability of getting a head and tail is 1. So these are 2 mutually exclusive. If you get a head, you don't get a toss. If you get a toss, you don't get a head. So these are collectively exhaustive. Whereas for the die, it is the same. Okay, but the mutually exclusive and collectively exhaustive events are 6 for throwing a die. Is that clear, guys? Any question? Yes, Chinon, what is your doubt? Focus. Can we do probability of higher for the first week? So probability for first week, conditional probability, higher for the year. So probability of higher for the first week. It all depends on what is asked. The 2 events are related to the first week performance and annual performance. So you can't do this. I think you have to go back to the formula which we have done. So go back to the formula. You just define what is event A, what is event B, and accordingly you need to follow. Okay, so we can't swap the conditional probability. I hope it is clear. Then we'll try to do this in some quiz questions. All right, now let us look at this example here. So this is again counting rules. So here a daily lottery is conducted. So there are 2 winning numbers. Okay, so out of 100 numbers. Okay, so here n is 100. Okay, how many numbers you're choosing? 2. So your x is 2. So you're asked to find out the sample space, how many different combinations of winning numbers are possible. So how many different combinations means, you know, NCR or NCX. So 100C combinations X2. So this is factorial n, that is 100 factorial over factorial x multiplied by n minus x factorial. So this is n minus x factorial. So n minus x factorial is 100 minus 2 factorial. So that gives you 98 factorial. So if you do this, so you can write 100 factorial is 100 into 99. So you can write this 98 97, etc., up to 1. Okay, so I'm just explaining the calculation. So this will be written up to 1. But the denominator, you have factorial 2 and factorial 98. So factorial 98 is you are multiplying now from 98 to 97 up to 1. So you are doing this up to 1. So you can easily cancel out these two things. So you can cancel out these two things. So we are writing only 100 multiplied by 99 over 2 factorial. So 2 factorial is 2 into 1, that is 2. So the calculation becomes simply 100 into 99 over 2. So that gives you 4,950. So is that clear, guys? So you are picking up 2 numbers out of 100 numbers. Okay, how many combinations are possible? So this is 100 C2. So that is factorial 100 over factorial 2 multiplied by 100 minus 2 factorial. So that is 98 factorial. So from the denominator, so you can write here 98 factorial. Okay, so the denominator also you have 98 factorial. So you can cancel out these two numbers. Okay, so you can cancel out this 98 here, 98 here. So the answer is 4950. All right, any doubt? Okay, I move on to the next question. Okay, this is again a combination based question. So there are 15 exercise bikes. So N is 15 here. You are choosing, select 3 of them. So your X is 3. And you want to display these things and how many different ways you can group these 3 to be selected. So again, we have the combinations. So N, C, X, N is 15, C combinations, X is 3. So we can write factorial 15 over factorial 3 multiplied by, so 15 minus 3 factorial. So that is 12 factorial. Okay, so now this 12 factorial you can cancel out from the numerator. So the numerator can simply 15 into 14 into 13. So factorial 3, you can write it as 3 into 2 into 1. So if you take this ratio, so the answer is 455. All right, any other questions, any doubt, guys? Probability is a very important concept, and this concept paves bridges the two things, the descriptive statistics and inferential statistics. So without probability, there are many things which we cannot model. We cannot interpret the results in a meaningful way. So therefore, probability is a very important concept, and it forms an important part of business statistics. All right. So next, let us go through some quiz questions. I expect your answers from you. So let us read the first question. So 2 events are collectively exhaustive. So what is the probability that one or the other occurs? So 2 events are collectively exhaustive. So then what is the probability that one or the other occurs? Anyone? So you are actually asked the total probability. So the total probability is 1. So the answer is not B, but C. All right. So the collectively exhaustive means the total probability will be 1. So then next question, if two events are collectively exhaustive, so what is the probability that both will occur at the same time? So question 2. So here we cannot actually find out from this information because we should know whether they are mutually exclusive or not. So the answer for this should be cannot be determined from the information given. So collectively exhaustive is not sufficient, but we also should know whether the two events are mutually exclusive or not. So for part 2, the answer should be D. Okay, then we move on to the next question. Okay, let us go through question 3. So two events are mutually exclusive, then what is the probability that both occur at the same time? So these are mutually exclusive. So that means if one occurs, the other one cannot occur. So here the probability, yeah, the answer, no, mutually exclusive. So the answer is 0. So if one occurs, the other cannot occur. So for example, if you pick up a card from a deck, the card can be either red card or can be a black card. Okay, and you cannot get both at the same time. So that is means the probability is 0. Okay, number 4. If the outcome of event A is not affected by event B, so then events A and B are said to be, yeah, so that's correct. So the two events are independent. So the probability of one event, outcome of one event is not affected by the outcome of another event. All right, I move on from here. Okay, next look at question 5. If either event A or event B must occur, okay, so event A or event B must occur, then events A and B are said to be, yeah, the answer is correct, collectively exhaustive. All right, let us move to question 6 then. The collection of all possible outcomes or possible events is called what? Yeah, that's right. It is a sample space. So it is the definition of sample space. Next, let us look at 7. So simple probability is also called as, so simple probability is not conditional probability. So simple probability is known as marginal probability. So the answer for 7 is A. Okay. Then question 8 is a descriptive question. Probably take a couple of minutes, go through and then try to answer. So the question reads as the probability that house sales will increase in the next 6 months is estimated to be 0.25. So the probability that the interest rates on housing loan will go up in the same period is estimated to be 0.74. Okay, the probability that house sales or interest rates will go up during the next 6 months is estimated to be 0.89. Now the events increase in house sales and no increase in house sales in the next 6 months. So here you can see the probabilities are not equal. Okay, so the probability of increase or decrease, so they are mutually exclusive. And also the total probability of this will leads to 1. So the answer is D. So both B and C. Okay, so for question 8, the answer both B and C correct. So therefore, you need to choose D, the option D. So they are mutually exclusive because the interest rate can go up or go down. So there are only 2 possibilities. So they are collectively exhaustive, means the total probability will be 1. All right, we can look at this question. So this is a scenario-based question. The 400 accidents occurred on a Saturday night were analyzed. So the total sample space is 400. Okay, the 2 items noted were the number of vehicles involved. Okay, so there are 3 possibilities: 1 vehicle involved, 2 vehicle involved, and 3 vehicle involved. So whether the drivers had alcohol play a role. So yes or no. Okay, so the number of vehicles involved 1 or 50 where there was alcohol had a role to play. Okay, so when the accidents were 2, so nearly the 100 cases where alcohol had a play. And when the accidents were 3, so the alcohol role was only in 20 cases. Okay, so the number of accidents involving 1 vehicle is 75. Okay, the number of accidents involved with 2 vehicles is 275. So similarly, 3 vehicles, the number is 550. So altogether, the total sample space is 400. Now, out of this, 120 cases, there is alcohol had a play, and 230 cases, there is no alcohol. So this is the scenario. So based on this scenario, there is a question in the next slide. Okay, so you may just capture this data, and based on this data, you can answer the following question. Okay, I clear this. Okay, so referring this scenario, so what proportion of accidents involved alcohol and a single vehicle? Alcohol and a single vehicle. So if I go back to the slide, previous one, alcohol and a single accident slide. So proportion of accidents involved alcohol and a single vehicle. So you can look at the data. So you can see alcohol and single vehicle is 50 right here. I think your answers are correct. So 50 over 400. So 50 over 400, you can see B. So the answer is B. Okay, again, question 10. Referring the above scenario, what portion of accidents involved alcohol or a single vehicle? So here you are dealing with R, so you have to use the additional rule. So you have to add what is the probability of alcohol. I type. So probability of alcohol play plus probability of single vehicle. Minus probability of alcohol and single vehicle. So if you do this calculation, then you will get the additional rule. So from the table, you can see probability of alcohol is 50 over 400. So you can say it is 50 over 400. So plus, so probability of single vehicle. So probability of single vehicle, how many single vehicles are there? So 75. So you will have 75 over 400. Minus, so probability of alcohol and single vehicle. Oh, and so 75. Probability of alcohol and single vehicle. Any answer from you? So probability of alcohol is 170. I'm sorry. Probability of alcohol is 170. Okay, so here probability of alcohol and single vehicle is 50 over 400. So if you do, what is your answer? Yeah, the answer is C. So you will get 195 over 400. All right. So the answer should be C. All right. I think I accidentally erased this. You can calculate again if you want. Okay, so the answer should be C. All right. I stop this. I think this is the last part of the quiz. Okay, then the summary of probability is again whether you should know the basic definitions of sample space and how to calculate probabilities from contingency tables. So whether we are dealing with one variable, then there is a simple probability. More than one variable, so we have joint probability and conditional probability. So you may then probability of and or. Okay, so the joint probability can be probability of A or B, or probability of A and B. So the conditional probability is a probability of A. So given that event B has occurred. Okay. All right. So with this, I stop here the chapter on probability.